All right, this says a particle moves along the x-axis so that its acceleration at any time t is given by a of t equals 6t minus 18. At time t equals 0, the velocity of the particle is v of 0 equals 24. And at time 1, its position is, I really should say x of 1 equals 20. Write an expression for the velocity of the particle at any time. Okay, so your velocity at any time is your velocity to start, and to start could be at any time value. They gave us the time value v of 0, so it's your velocity at the beginning of the situation plus how your velocity changes from 0 to whatever time you are interested in, and this is going to be your acceleration. So I got to use a different variable here, okay, but that's going to be the scaffold for your velocity. Let's put in the particulars now. Velocity is v of 0, that's 24. So your velocity is 24 plus the integral from 0 to t, and your velocity, or your acceleration function, is 6t minus 18, which we'll write as 6w minus 18 dw. Now there's actually nothing wrong with this expression here. So, given a calculator, you could leave it like this. This is a legitimate expression, and it just says write an expression. I'm going to go the extra mile here, though, and do a little more. And by that I mean I'm actually going to find a closed form for my velocity, because this antiderivative can be done using the fundamental theorem. So I'm just going to clean this up a little bit. This is equal to, let me zoom in. So this is equal to 24 plus, so now I'm going to do an antiderivative of 6w minus 18, which is 3w squared minus 18w evaluated from 0 to t, which is 24 plus 3, I'm plugging in the upper limit of integration there, 3t squared minus 18t. And there it is. And plugging in 0, of course, makes the w 0, so I didn't even bother. And I've got my velocity function. V of t is equal to, I'm going to rewrite this in a more standard form, 3t squared minus 18t plus 24. Okay, so there's part A. Okay, I'm being a little bad with spacing, so I'm just going to move this slightly. The next question says, for what values of t is the particle at rest? So a particle is at rest when the velocity is equal to 0. Okay, at rest means to not be in motion. That does not necessarily mean it changes direction. It just means it is not in motion at that time. Okay, so that was part A. Part B is, let me kind of check off as I do them. For what values of t is the particle at rest? So at rest means that your velocity is equal to 0. And so let's go figure out when that happens. I've just taken some time to find my velocity function. It's 3t squared minus 18t plus 24. I'm going to set that equal to 0. And I can factor this. I'm going to factor out a 3, leaving behind t squared minus 6t plus 8. And taking a few seconds to factor, it gives me t minus 4, t minus 2. So it looks like at times 2 and 4, the particle is at rest. Part C says, write an expression for the position of the particle at any time t. So your position at any time t is your position at the beginning of the situation. Now notice, for the initial condition they gave us, it's at time 1. So it's my position at time 1, plus how my position changes from 1 to whenever. And then I have my velocity function here. And in a similar fashion, let's get something concrete here. So therefore, x of t is equal to my position at time 1, they told me was 20, plus the integral from 1 to t of my velocity function, which you see above, 3w squared minus 18w plus 24 dw. Okay, now I can evaluate this. I can evaluate this by using the fundamental theorem as I did before. So an antiderivative of 3w squared minus 18w plus 24 would be w cubed minus 9w squared plus 24w, evaluated from 1 to t. So this gives me 20 plus, so notice plugging the upper limit of integration just turns the w's to t's, so it's t cubed minus 9t squared plus 24t. And then I get a minus what I get when I plug in the lower limit of integration, which is that 1. If I do this in my head, I think it's, 1 isn't so bad to evaluate. 1 cubed minus 9 times 1 squared is negative 8, plus 24 is a 16, so I get a minus 16. Okay, so let's move it up here. My position function in the end would be, we can combine these here. The 20 minus the 16 gives you a 4. Nope, it gives you, yeah, it gives you a 4. So I get t cubed minus 9t squared plus 24t plus 4. That is my position at any time. Okay, and the next thing, or the very last thing I have to do at this point is this last question. Find the total distance traveled by the particle from t equals 1 to 3. So to do that, I need to evaluate the integral. So total distance is just the integral from 1 to 3 of my velocity in absolute values. So let's use technology for this. Okay, I've got my velocity function in my window, so I'm going to integrate. So I hit math. Integrate. We're integrating from time 1 to time 3. I need my absolute value bars. I hit math. I go over to number, absolute value, and then I put in my velocity function, which is 3x squared minus 18x plus 24. And I get 6. All right, and so that brings me to the end here. I've done all the problems. Some of them I used the fundamental theorem. Obviously, that last one I just relied on technology. But that gives you a good overview of the style of questions that can be pitched at you involving position, velocity, and acceleration.